I am IPSITA GHOSH. I am the Assistant Professor of Swami Vivekananda Institute of Science and Technology, and today I am going to discuss on the topic of Z transformation. We know that the transform techniques are very much important tools in the analysis of signals and especially on the linear time invariant system. So here I am introduce the transformation, which is Z transformation. It is observed from that Laplace transformation. It is an extension of the continuous time Fourier transform because of the fact that Laplace transform may be applied to a broader class of signals than the Fourier transformation. But in that case, the Z transform plays the same role in the analysis of discrete time signal and linear time invariant system as the Laplace transformation plays in the analysis of continuous time signals and linear time invariant system. This means that Z transform is the discrete time counterpart of the Laplace transformation. So why we need Z transformation? Because it is a mathematical tool which is commonly used for analysis and synthesis of the discrete time control system. Z transform in discrete time system plays a similar role as the Laplace transform in the continuous system, as I am saying previously. So basically the Z transform is the most general concept of the transformation of discrete time series. That means it is converting from the time domain to frequency domain. But that means one time domain signal is converted to a frequency domain signal. Here the term Z is basically a complex variable which I am taking equal to e to the power j omega, where omega is real and mod z equal to is one value. So the expression of bilateral Z transformation is, now what is bilateral Z transformation? In the signal scale range, there are two sides, in the positive side and the negative side. And in case of bilateral Z transformation, I am considering both sides. The expression is considering both sides from minus infinity to plus infinity. The expression is xz equal to summation over n equal to minus infinity to plus infinity xn z to the power minus n, where xz is the Z transformation of xn. xn is a discrete time signal and whose transformation in the Z transformation is xz equal to summation over n equal to minus infinity to plus infinity xn z to the power minus n, where z is a complex variable. So this is called the direct Z transformation due to the fact that it transformed the time domain signal xn into its complex plane representation xz, where xz is the Z transformation of xn, and in that case that limit is from minus infinity to plus infinity. That means I am taking the range from negative side to positive side, so it is known as bilateral Z transformation. And the next is one-sided Z transformation. In that case, show the limit of the summation which is n equal to 0 to infinity. That means I am taking only the positive side of Z transformation. xz summation over n equal to 0 to infinity xn z to the power minus n. This is also called unilateral Z transformation or one-sided Z transformation or positive sided Z transformation. So some advantage of Z transformation in case of LTI system, because the discrete time signal and the LTI system can be completely characterizing by using Z transformation. The stability of LTI system can be determined by using Z transformation. Many mathematical calculations are very much reduced by using Z transformation. By calculating Z transform of given signal, we can calculate DFT, discrete Fourier transform, entire family of digital filters can be obtained from by using the Z transformation, calculation of Z transformation, where the solution of differential equations can be also simplified using Z transformation. So there are two types of Z transformation, as I am saying, single sided and double sided. In case of double sided, it is also known as bilateral, and the single sided is also known as unilateral Z transformation. So what is Z domain? Basically, we are transforming discrete time sequence xn into xz. So we know that discrete time sequence xn is drawn simply by plotting amplitude versus n, and this is known as discrete domain. And in case of Z transformation, we are plotting real part of Z on the x-axis and the imaginary part of z on the y-axis, and this is known as z domain, and this is our z plane, the same concept as z domain. On the x-axis it is denoted real of z transformation, and on the y-axis it is imaginary z, and the formation is r e to the power j phi. So next I am discussing about poles and zeros. When xz is a rational function, and we know the rational function means it is in the p by q order, where q is not equal to 0. That means when the xz is a rational function, that means a ratio of polynomials in z, then the roots of the numerator of the polynomials are referred to as the zeros of xz, and the roots of the denominator of the polynomial are referred to as the poles of xz. Suppose xz is a rational function like pz divided by qz. So pz is the numerator of xz and qz is the denominator of xz. Now we know in case of polynomial, when polynomial is equal to 0, then we have the roots of the polynomial. So in that case, the numerator is also a polynomial pz and the denominator is also a polynomial qz. If we put pz equal to 0, then we have the roots of the numerator polynomial, which is known as zeros of xz. Why they are known as zeros of xz? Because in case of xz equal to pz by qz, if we put pz equal to 0, so if we put pz equal to 0 in the expression xz equal to pz divided by qz, we have the values xz equal to zeros. So that's why the roots of the polynomial pz is known as the zeros of the polynomial rational function xz. Now the roots of the denominator polynomial are referred to as the poles of xz. So if we put qz equal to 0 in the expression of xz equal to pz divided by qz, if we put qz equal to 0, then the xz has the value infinity, because we know xz equal to pz by 0, it is equal to infinity. So at infinity means I am telling the value, infinity means the poles value. So at poles we have the infinity value of xz, and at zeros of xz we have the 0 value of xz. So xz equal to pz by qz, if the polynomial pz equal to 0, then the roots of the numerator polynomial are referred to as the zeros of the xz, and the roots of the denominator polynomial are referred to as the poles of xz, and the zeros is denoted by a small circle in the diagram, and the poles are denoted by a cross sign in the diagram. So next I am discussing about region of convergence. Now what is region of convergence? The set of values of z in the z plane for which the magnitude of xz is finite is called the region of convergence. First we have to know what is the meaning of convergence. That means in the region where I am getting some finite values. Suppose x equal to 2 by 0, it is equal to infinity. That means x is not converge because it has a finite value. If I am taking x equal to 2, that means it is converges to a value which is a finite value. So in that case, xz equal to a rational function. That means the ratio of some polynomial pz by qz. In that case, the values of z for which the xz has a finite value, so then these values of z are known as the region of convergence, and obviously the z values are in the plane of z plane. So the set of values of z in the z plane for which the magnitude of xz is finite is called the region of convergence. As I am previously saying that at pole the xz has a infinite value, so here saying that region of convergence does not contain any poles. Obviously, because region of convergence means where xz has a finite value, and at poles the xz does not have any finite value, so obviously region of convergence does not contain any poles. In the next slide I am giving one example, then this must be clear. So suppose let xn equal to a to the power n un. So it is a positive sided signal because un is a unit step discrete signal, which is started from 0 and going to the positive side taking the value 1. Unit step signal means it has a 1 value from 0 to infinity in the positive side. So xn equal to a to the power n un, it is a positive sided signal. So the expression, in the expression of z transformation, xz equal to summation over n equal to minus infinity to plus infinity xn z to the power minus n. In that case, we have to put the value of xn, which is a to the power n un. Now xz equal to summation over n equal to minus infinity to plus infinity a to the power n un z to the power minus n. In that case, the range is from minus infinity to plus infinity, but the range of un, that is unit step signal, which is ranges from 0 to infinity value. So by taking minus infinity to 0, it is 0 in the negative side. So the equation becomes summation over n equal to 0 to infinity a to the a z inverse whole to the power n. Actually it is a to the power n z to the power minus n. It is common of a z inverse whole to the power n. Now by applying the series formula, which is convergence to xz equal to 1 by a minus a z inverse, 1 by a minus 1 by 1 minus a z inverse, and it is equal to z by z minus a. Now the xz equal to z by z minus a, where the numerator is z and the denominator is z minus a. Now this will be converges if mod z has the greater value of a, because if mod z equal to mod a, then xz has a infinite value. So if we have mod z greater than a value, then xz has a finite value. So which converges to xz z by z minus a for mod z greater than a value. So xz equal to z divided by z minus a. If we have to find the poles and the zeros of this xz, then we have to put the numerator equal to 0. In that case, the numerator equal to z. So z equal to 0. Z equal to 0 is the zeros of the polynomial xz. Z equal to 0 is the zeros of this xz. And if we have to find the poles of this xz, then we have to put denominator equal to 0. Denominator in that case is z minus a. So z minus a is equal to 0. If we put z minus a equal to 0, then we have z equal to a. So z equal to a is the poles of this xz. So z equal to 0 is the zeros of xz, and z equal to a is the poles of xz. So in this figure, as I am previously saying, zeros is denoted by a small circle and the poles is denoted by a cross sign. Here the origin, in the origin position, a small circle is drawn which is z equal to 0, and in the a position a small cross is drawn which is the poles value. So this is xz has a 0 at z equal to 0 and has a pole at z equal to a. Next we are going to properties of region of convergence. The region of convergence ROC for a given discrete time transfer function is a disk or annulus which contains no pole, as in I am going to the previous slide. In that case, a small circle is drawn with some radius a. So this circle is denoted in case of ROC. The region of convergence for a given discrete time transfer function is a disk or annulus which contains no poles. If the ROC includes the unit circle, then the system is bounded input and the bounded output stable system. If the ROC include the unit circle, that means I am drawing, I am giving one circle whose radius value is equal to 1, and if this unit circle includes ROC, then it is said to be that the system is bounded input, bounded output, stable system. If the ROC extend outwards from the pole location, if the ROC is extend towards the outside, that means it will go up to infinity with the largest magnitude, but not infinite, not going to the infinity. Before infinity, suppose it take any finite value which is very much largest but not infinite, then the system has a right-sided impulse response. Next, in general, the ROC is not unique. and the particular ROC in any given case depends on whether the system is causal or anti-causal. If the ROC extend outward from the pole location, if the ROC extend outward side with the largest magnitude and there is no pole at infinity, then the system is called causal system. And if it extend inward from the pole location, the ROC extend inward side with the smallest magnitude but not equal to 0. In the previous case it is not equal to infinity, in this case it is not equal to 0 magnitude. So if the ROC extend inward from the pole with the smallest magnitude, then the system is anti-causal. So ROC in any given case depends on whether the system is causal or anti-causal. If it is outward from the pole, so it is causal, and if it is inward to the pole from the pole, so it is anti-causal. Next, if you need stability, then ROC must contain unit circle. Now what does it mean, unit circle? We are drawing one circle whose radius is equal to 1, and if ROC contain this kind of unit circle, then we are contributing about stability of the ROC. So if you need stability, then ROC must contain the unit circle. If you need a causal system, then the ROC must contain infinity and the system function will be right-sided sequence. As in the previous point, if the ROC extend outward from the pole, then the system is causal. And in this point, if you need a causal system, then the ROC must contain infinity and the system function will be a right-sided sequence as shown in the figure. In the 0.5, after 0.5, the whole blue region is the ROC and it will go up to infinity, not the infinity value, it will go up to infinity. So the system function will be a right-sided sequence. If you need an anti-causal system, then the ROC must contain the origin, as I am saying in the previous one, the interior part from the poles. If you need an anti-causal system, then the ROC must contain the origin and the system function will be a left-sided sequence. The smallest circle whose radius is 0.5, in between region, the blue region is whole blue region is ROC. And if you need an anti-causal system, then the ROC must contain the origin and it will also contain the origin. So the system function will be a left-sided sequence. And if you need both stability and causality, so all the poles of the system function must be inside the unit circle. In that case, one unit circle is drawn in the outside and in between 1.5 circle and 1.75 circle is drawn. So in between the annular region, the blue region is called the ROC. So if you need both stability and causality, all the poles of the system function must be inside the unit circle. So these are the properties of ROC, which is basically plays an important role to finding the Z transformation and the finding the convergence of the Z transformation of XZ. Okay, thank you.